All right, so today what we're going to be looking at is, I didn't have a chance to really go over these notes, so I wanted to go over. You'll have to excuse the copier that's going on in the background. I'm trying to run things off. So let me start with, let me get on my first page. All right, so what I wanted to do is just take a minute and go over and make sure everybody knows what energy flow and all that good stuff is. So when you're looking at the levels of organization, let me get my little thing. Species are anything that can breed with each other. So a population is made up of the same amount of species. And then a community, here's the key here. The community is different species, but they are living things, okay? Ecosystem includes the physical factors and the living things. And then a biome is just has the same type of climate. And then your biosphere is the whole earth. Okay, so let's go through some energy flow. If you're looking at, and you guys were great with this, you seem to have remembered all this. Remember, herbivores eat plants, carnivores eat meat, omnivores eat both, and decomposers eat organic matter. Okay, you told me that sunlight was the main source of energy. That is that's the whole purpose of this. And if we look, let's see if I can get this to scroll up. If I look, there's two ways in which you can be an autotroph. If it's photosynthesis, then you're using sunlight for your food. If it's chemosynthesis, then you're using chemicals to make your food. Now, if we look here, let me go to my next page. The difference between a food chain and a food web. So your food chain only shows one direction, okay? So it's like one way. If I'm looking at a food web shows all the feeding relationships. Okay? And each of these each of these steps are trophic levels. So this primary consumer, that's its trophic level. It is going to eat from the producer. This secondary consumer, that's the next trophic level. It's going to eat off the primary. So each of these are stages or levels in the food chain. Remember that decomposers can be at every level because we all die, okay? Everything is going to die. Now, I'm going to scroll up because you had this tonight for homework. You had to identify these different things. So let's look at our energy pyramid. I made the comment to you today that only 10% goes to each trophic level. So if you'll notice, let me erase what I just did here. You see how my numbers, it started off as 100, so then I get 10% of that, 1%, and then 0.1. So let's put this into a math problem. If I had 15,000 kilocalories of energy, how much would the hawk get? So let's say I started down here with 15,000. If I'm getting 10% each time, this is going to be 1,500. This will be 150. And so your hawk is going to get 15. That's why there's a limit to how much energy can be, how many links there can be in a food chain. Okay. Now, in terms of toxins, here's a little bit different. Toxins accumulate as you go up the food chain. Okay, so they do not break down. So that's why when you look at something like DDT, which was used as an insecticide, they banned it because what happens is as it goes up, it doesn't break down. So, let's say that chemical was sprayed here and you got all these little particles. As these different organisms ate that, you get even more particles. And then because it doesn't break down in their tissues. And then as you continue, as these organisms eat these, notice I'm getting more and more and more until finally, if I look at that top level consumer, they have all these toxins built up in their system. Okay. Unlike energy, toxins accumulate. We don't lose energy, but only 10% is transferred for each level. All right. So let's scroll down. In terms of nutrient cycles, your nutrient cycles are the chemical substance that help us maintain life. The key things that I want you to remember about the carbon cycle is photosynthesis uses CO2 and takes CO2 out of, so it takes it out of the environment, okay? We put it back in the environment by breathing or by burning things. So the question, how does deforestation affect CO2? It's going to increase the amount of CO2. Sorry for my sloppy handwriting. Okay, so let's look at nitrogen cycle. Nitrogen is needed for making proteins. Okay, and so it's very important. Plants cannot just take nitrogen out of the atmosphere, even though it's the most abundant gas. So bacteria have to fix it in some way. And when they fix it, we get it by eating the plants or the animals that ate the plants. And then, of course, as we, let go of waste and different things, it gets returned to the atmosphere. Now, the phosphorus cycle, which is used as far as is needed in our DNA, it's basically formed from the decomposition of eroding rock. All right, let's see. What else do I have? So the last bit is, so what's the difference between energy flow and nutrient cycling? Flow means it's going in one direction. So energy cannot be recycled, okay? Whereas nutrients are recycled over and over. Primary productivity is how much matter is created by producers in a specific amount of time. So something like the rainforest is going to have a high amount of primary productivity. And if you hear the word limiting nutrient, that's going to limit how much productivity there is. For example, the deeper you go in the ocean, light is going to be a factor, okay? You know how when you have fertilizers, farmers spray their fields and then there's a huge rain and it gets washed off into the ditch. What does that cause? Algae blooms. So when you see a bunch of algae blooms, you know that there's a lot more nutrients in that water than what's needed to be. And what that causes is basically all the oxygen gets starved out of the water and it leads to fish kills and things. So too much fertilizer in an environment is not a good thing. And one of the key indicators that you have that is these huge algae blooms. Okay, so that's just a quick and dirty review of nutrient flow and cycling.